Okay. හැමෝටම මාව ඇහෙනවද? Okay. Shall we start? Please mark your attendance. Please go through that link and mark your attendance. Okay. Okay. I will start the session. Today we are going to discuss about Kirchhoff's law. හැමෝටම මාව ඇහෙනවද? කවුරු හරි ආන්සර් කරන්නකෝ එක්කෙනෙක්.
ඇහෙනවා.
හරි. Okay. link එක තියෙනවා chat එකේ. ඒකෙන් ගිහිල්ලා ඔයගොල්ලන්ගේ attendance mark කරලා එන්න පළවෙනිටම. mark කරපු නැති අය attendance mark කරලා එන්න. 32ක් ඉන්නවා. ඒ වුණාට තාම 16 දෙනෙක් විතර attendance mark කරලා තියෙන්නේ. Please mark your attendance. There is a link in the chat. Go through it and mark your attendance. Okay. Today I'm going to discuss about Kirchhoff's laws.
Attendance not work.
It's working.
Attendance link.
It's working. It's working. There is no problem with that one. 22 people are marked their attendance. So I think there is no problem with the link. It's working. I will send it again. Okay. First, I'm going to discuss about Kirchhoff's first law. By using Kirchhoff's first law, we can mark the current of the circuit. Okay. Now, first I will give you the first law. Wait.
මේක මේ සිංහල පාස් version එක නේද?
සිංහලෙන්ද මං කරන්න ඕනේ ඉංග්‍රීසි වලින්ද? සිංහල
ඔව්
ඉංග්‍රීසි වලින් දෙකෙන්ම
මේක postpone කරලා ගිහලා ඒක.
ඉංග්‍රීසි වලින් තව එකක් තියෙනවා කියලා නෑ. පාස් සෙෂන් එක නෙමෙයි ලෙක්චර් එක මං හිතන්නේ. අද ඔයාලට තිබුණා ලෙක්චර් එක. ඒ ලෙක්චර් එක postpone ලානේ තියෙන්නේ.
Yes,
ඔව්
sir.
Yeah. This is I will please raise your hand student who need to do it in English. Otherwise, I can continue it in Sinhala. Yeah, there are a lot of students asking for the. Some students are asking for the. Yes. Okay. Then I will do it in English. Okay. Okay. First, I'm going to talking about Kirchhoff's law, Kirchhoff first law. Okay. In Kirchhoff first law says the sum of the all currents entering to the junction is equal to sum of all current leaving the junction. I will copy it here. I think it is in your book also. When we are talking about this one, if you are considering a junction of the circuit like this, first we considering a normal junction. You know, in our roads, there are a lot of junctions. No. So when we are considering a junction in our road, okay, if 20 cars are entering this way and 10 cars are entering this way. If 18 cars are leaving the junction in this way, how many cars leaving this junction in this way? Can anybody tell me?
12.
Sorry?
12.
Yes, it's 12. Just like that, in this case, when we are considering a junction in a circuit, when 10 ampere, we'll take 20 ampere, 20 ampere current. 20 ampere means within 1 second, there is 20 coulomb charges are coming into the junction. And 10 ampere current is entering to the junction in this way. If in this way, 18 ampere current is leaving the junction, we can say 12 ampere current is leaving the junction in this way. Is it clear for everyone?
Yes, sir.
Yeah. Then in another way, I can say it like this. You know, current is a direction of positive charging, positive ions move in direction or negative ions move in direction. Current is direction of the current means positive ion to move in direction or negative. Yeah, positive ion move in direction. Then you can say if there is 20 plus 20 coulomb charges are coming into junction in this way, we can say no, there is minus 20 coulomb charges is going into this way. Am I correct? Is it clear for everyone? Is it clear?
Yes.
Okay. Then I will redraw this diagram like this. I can say if 20 ampere current is entering to the junction in this way and 10 ampere current is entering to the junction in this way. And I will draw these parts like this. Minus 18 amperes are entering to the junction in this way and minus 12 ampere current is entering to the junction in this way. Is it clear for everyone? Same thing. What I am doing is I am considering the direction of the negative ions moving direction. This means negative 18 coulomb charges per seconds are coming into the junction in this way. Is it clear for everyone? Is it clear or not?
Yes, sir.
Then I can say if you are considering the sum of the all current entering to the junction is equal to 0, just like this. 20 amperes, when you are considering all the currents are entering into the junction, we can write it like this way. It is 10 amperes plus minus 18 amperes plus minus 12 amperes. It is equal to 0. So we can represent Kirchhoff's first law like this. If you are considering the I1 current is entering to the junction in this way, and I2 current is entering to the junction in this way, and I3 current is entering to the junction in this way, and I4 current is entering to the junction in this way. We can say summation of I1, I2, I3, and I4 is equal to 0. In another terms, sigma I is equal to 0. This is a mathematical representation of Kirchhoff's first law. Is it clear for everyone or not? Is there any
Yes, sir.
okay?
Yes.
In another terms, Kirchhoff's first law says, what Kirchhoff's first law says, it says charges are conserved. Just like momentum conservation, just like energy conservation, charges are also conserved. That's what's saying in this law. The sum of the all current entering to the junction must be equal to the sum of all current leaving the junction. In another terms, sum of the all algebraic summation of the all current entering to the junction, algebraic summation. That means I'm considering the negative and positive values. There is another thing I have to tell you. Sorry, someone asking question. Sorry. Are there any questions? Please ask me now. Any questions? Okay. Then, in another terms, this Kirchhoff first law is always says the charges are conserved in electrical circuit. Okay. Is it clear for everyone, or any other doubts about this one? Are there any doubts? Any doubts?
No.
Okay. Then I'm going to the Kirchhoff's second law. I will show you my slides. Sometimes it can be a little bit hard to understand, but anyway, if when we are discussing in it calculations, you will understand it correctly. Okay. In Kirchhoff's second law, what he says, along the cyclic direction considered within a selected closed loop. Those are very important terms. Along the cyclic direction considered. That means we should have considered, okay, within selected closed loop. An electrical current network, the algebraic summation of the electromotive forces. These terms are really important when you are writing this second law, okay, is equal to the sum of the product of the current and the resistance. Okay, these terms are really important. Okay, these are the point we should have consider when we are writing a Kirchhoff second law. Otherwise, you will be lost some mark. I will highlight it. Along the cyclic direction of considered within selected closed loop of an electric circuit network. The algebraic summation of the electromotive forces or EMFs equal to the sum of the production. sum of the production of current and the resistance. Okay, we can represent it as sigma E is equal sigma ER. We will discuss it further in our questions. Okay, I will not going to deeply discuss about how the mathematical representation is coming into the Kirchhoff law. So the main purpose of this session is going to the questions. So there are a lot of questions we have to do today. So I will discuss in step by step. Okay. First, now I think both of Kirchhoff's laws are clear to you. Am I correct? Is it clear to you? Everybody can understand it?
Yes, sir.
Okay.
Yes, sir.
Then you have to remember few more things. Okay. When we are considering the battery, this is a short form. Okay. When you are doing a Kirchhoff laws, this is a short form to easily applying the Kirchhoff laws into the circuit. Okay. Okay. When we are considering a battery, I'm going to consider the short one is as a security. Okay. And the long one is, this one is the positive and this one is negative. Okay. Anyway, I'm going to consider this one as a security. Then the large one is as the principal. If you are going to security job to the principal job, is it a promotion or demotion? If you are going to security job to the principal job, is it a promotion or demotion? Anyone? If you are going to the security job, then you got a principal job. Is it a promotion in your?
Promotion.
Yeah, it's a promotion.
Promotion.
If you are going to principal job and you are getting security job, is it a demotion or promotion?
Demotion.
Demotion. If it is a promotion, principal to security. If it is a promotion, is it negative or positive? It's a positive thing or negative thing?
Negative.
When we are going to principal to security, it's demotion. It's demotion. Is it a promotion? Is it a negative or positive?
Negative.
Negative thing. When we are going to security the principal, it is a promotion. That promotion is a negative or positive thing? It's positive. Please remember these things. It's easy to it will be easy to you to understanding my concept regarding this Kirchhoff's law. Okay. First, I am going to talking about this circuit. 6 to 10 6. Ten volts, 6 volts, and 6 ohms and 2 ohms. Now, first, I'm going to how many loops are there? How many loops are there? Loops in this circuit? How many closed loops?
One
Oh,
loop.
yeah, yeah.
One.
There is only one closed loop. So I'm going to mark that closed loop as A, B, C, D loop. Okay, it's A, B, C, D loop. Now, first, I'm going to start the mark current from largest EMF values. the largest cell. What is the largest cell in this circuit?
Volt 10.
10 volt. I'm going to start from that 10 volt. The current is coming out from the 10 volt and going to this junction. There is no other way, so it's turning into this direction. I will draw it in different color. Okay, it's simple line, and it's come to this point, and there is no other way, so complete current is turning into the direction B. Then it's going to I. There is no changing because of the resistor. There is no changing of the current. This one is without any changing. It's flow through this 6 ohm resistor and going to the 2 ohm resistor and going to this direction and this direction and again come into the negative terminal of the 10 volt battery. Is it clear to you, or do I need to say repeat
Sir,
it?
how did the I didn't understand that resistor part, sir.
So there is no changing in resistor because first you should consider it as like this. First, this current is overall consider about the loop and identify how many charges can be flow through this loop. So when I charges are coming out to the 10 volt resistor, there is no changing of the current if it is go through 6 ohm. Is it clear or not? There is no changing. කිසිම වෙනසක් වෙන්නේ නැහැ නේ කරන්ට් එක මේක through ගියා කියලා 6 ohm එක හරහා ගියා කියලා.
Excuse me, sir.
Yeah.
There is a gap between those two batteries, so
No, don't consider that one. Just like this, if you are taking out I current from 10 volt battery, that I current should be coming to the negative terminal of that battery. Is that logic is clear to you?
yeah. Okay.
Then that's all. Is it clear? That's all. There is no increment.
ඉඳන් 10 වෝල්ට් වල නෙගටිව් එකට එන කියන කරන්ට් එකත් අරකවද නැත්නම් බැටරි දෙක අතර කියලා කියනවද නැත්නම්
නෑ.
දෙක එක මත එකද?
දැන් මම 10 volt වලින් current එක එළියට ඇද්දේ.
ඔව්.
එතකොට I current එක එළියට ඇද්දේ.
ඔව් ඒක හරි.
දැන් එතන current එකම ආයි එන්න ඕනේ නේද මෙතනට? එහෙම නැති වුණොත් එimhe charge conservation එක නැති වෙනව නේද? ආරෝපණ සංස්ථිතිය නැතිලා යනවා.
වෝල්ට් වල නෙගටිව් වෙනකන් එනවා. හරි.
ඔව්. එතකොට ආයි මේකේ නෙගටිව් ටර්මිනල් එකට වෙනකම්ම I එකම එන්න ඕනේ නේද? ක්ලියර්ද නැද්ද?
නෑ ඒක ක්ලියර් මැදට එක්ස්ප්ලেইন කරන්න පුළුවන් ක්‍රමයක් නැත්නම් ටිකක් ක්ලියර් වෙන්න කියන විදිහට අපි අර මේ කොස් මොනවාද මේ සෙල්ස් අපි සාමාන්‍යයෙන් යූස් කරලා දැකලාම නැහැ අපිට
මේ බලා ගන්නකො.
ඔය විදිහට
මෙතනින් අපි කියමු කූලෝම් 10ක් එළියට ආවා කියලා. ඔයාට මාව ඇහෙනවද නැද්ද? කතා කරන්නේ කවුද කියන්නේ බලන්න. නිපුන්. හරි.
මම
ඕකේ. එතකොට කූලෝම් 10ක් එළියට ආවයි කියන්නකො. ඒ කූලෝම් 10 එළියට එන්නේ දැන් මේ කූලෝම් 10 මෙතනින් එළියට එන්න හේතුව තමයි හරිද? මේ බැටරි එක හරහා යාගේ නෙගටිව් ටර්මිනල් එකට යන්න බෑ. මේක ඇතුලේ සෙල් රියැක්ෂන් එකක් තියෙන නිසා. ක්ලියර්ද කියන එක? බැටරි එක හරහා 10 කූලෝම් ටික එහා පැත්තට යන්න පුළුවන් වුණා නම් මෙතන නෙගටිව් කට්ටියට එකතු වෙන්න පුළුවන් වුණා නම් එයාට ওই ප්‍රශ්නේ නැහැ. පැහැදිලිද කියන එක?
ඔව්.
දැන් මම මොකද කරන්න ඕනේ? මම පටන් දැන් මෙතනින් ඇතුළට යන්න බැරි නිසා මම කරලා තියෙන්නේ වයර් එකක් දාලා තියෙනවා මේක through. ක්ලියර්ද කියන එක?
ඔව්.
එතකොට අර 10 කූලෝම්ස් එක තමයි මෙතනින් එළියට එන්නේ. තේරෙනවද කියන එක? එතකොට ඒ 10 කූලෝම්ස් ටිකම නෙමෙයිද once again මෙතනට එන්න ඕනේ. ඒක ක්ලියර්ද කියප එක නැද්ද?
ඔව් සර් ඒක හරි. හරි.
එතකොට මේ තැනදි ගත්තත් මම මෙතන අරන් තියෙන්නේ තේරුම් නැත්නම් ආයෙ අහන්න. මම මේ තැනදී අරන් තියෙන්නේ සිම්පල් i කියලා අරන් තියෙන ඔය තප්පරයකදී within 1 second i coulombs ප්‍රමාණයක් යනවා කියන එකනේ. ඔතන අයිඩියා එක.
ඔව් සර් හරි.
හරිද? එතකොට ඒ i coulombs ටිකම ආපහු සැරයක් මේ බැටරි එකටම එන්න ඕනේ. නැත්නම් මේ බැටරි එකකින් ගියපු chargers ටික අඩු වෙලා මෙතනට ආවොත් හරි වැඩිලා මෙතනට ආවොත් හරි එතන Kirchhoff first law එක මොනවාද මේ violate වෙනව නේද?
ඔව් සර්. ඔව් ඔව්.
charge conservation එක නෑ. ක්ලියර්ද කියන එක. දාපු
හරි,
ප්‍රමාණය එළියට
හරි.
එන ප්‍රමාණයට සමාන වෙන්න ඕනේ. junction
හරි,
එකදී
හරි.
වගේම මේ loop එකකදීත් එහෙමයි. මෙතනින් ඇතුළට දාපු ප්‍රමාණයම තමයි මෙතනින් එළියට එන්න ඕනේ. කොහෙවත් යන අතරමැදකදී වැඩි වෙන්න හෝ අඩු වෙන්න බෑ. ක්ලියර්ද කියන එක. අනිත් අයටත් ඒක තේරුණාද?
ඔව් සර්.
Others can also understand that one?
Yes, sir.
Okay.
Yes sir.
Then now that's all for the Kirchhoff first law. Now I'm going to apply the Kirchhoff second law to this circuit. Okay. මම දැන් කරන්න යන්නේ දෙවෙනි law එක Kirchhoff ගේ දෙවෙනි නියමය මේකට apply කරන්නයි යන්නේ. Now if I am applying Kirchhoff second law to this circuit, first I should consider a direction. It can be either counterclockwise or clockwise. That means you can consider the direction of current, or otherwise if you want you can consider the opposite direction of that one also. Is it clear? හැමෝටම තේරුණාද? ඒ කියන්නේ ඔයාලට කැමති නම් current එකේ un direction එකම consider කරගන්න. එහෙම නැත්නම් current එකේ un direction එකට opposite direction එක consider කරගන්න. ඒක clearද හැමෝටම?
Yes, sir.
ඒ clear නැත්නම් කියන්න. Is it clear or not? If you have any doubt please tell me.
It's clear sir.
Sorry මේ නිපුණාට තේරුණාද ඒක?
ඔව් සර්. It's
Hari,
clear.
okay. Okay, now I'm going to applying for the first one. I'm going to applying the direction of the current. Okay, that means I'm going to applying Kirchhoff second law to the clockwise direction. Okay. Now you can start from any point. Any point. Which point you would like to start? A, B, C, or D?
Let's start with
Sorry? D.
A.
A. Okay.
A.
Okay. Now I'm going to applying Kirchhoff first law to A, B, C, D, A loop. So first I have to write what is a loop I'm going to consider. A, B, C, D, and A. A, B, C, D, and A. The direction is this direction. Okay. Now I'm going to apply sigma E is equal sigma IR. Is it clear? Up to that part, is it clear or not?
Clear,
Clear
sir.
sir.
Okay. Now first I am going to considering only about EMF values. When we are considering EMF values, don't consider about current and the resistor values. Okay, current and the production of current and the resistor do not consider when we are talking about EMF value. Is it clear or not? Clear than other recording
Yes,
on it?
It's clear sir.
Is it recording? Yes, it's recording. Okay. Now I'm going to applying Kirchhoff second law from this A point. Now I'm moving from A point. Are there any cells or EMFs?
No.
No.
Are there any cells or EMFs?
No.
No. Are there any cells or EMF?
No.
No. Any?
No.
Are there any cells or EMF?
Yes.
Now we have to consider who is the first job. The security or principle? What is my first job?
Security.
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 Then I am moving to the
Principal.
principle. Is it a demotion or promotion?
Promotion.
It's promotion.
Promotion.
Is it positive or negative?
Positive.
So it's positive 6. Is it clear?
Yes.
Now, is it security or principle?
Security.
To principle. Am I correct?
Principal.
Is it
Yes.
demotion or promotion?
Promotion.
Promotion. Is it positive or
Same.
negative?
Positive.
Positive. Then positive 10. Is it clear?
Yes.
Now, there are no other EMFs or cells. Am I correct?
Yes.
Yeah.
Now I am going to consider about sigma IR term. Now I'm again starting from A. And are there any resistors?
No.
No. Are there any resistors?
Yes.
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 First, you have to find out the current is going into your considered direction or opposite direction. Is it going to the considered direction or opposite direction?
Consider
Consider.
direction.
Considered direction. Is it then we are considering about positive charges moving direction or negative charge moving direction?
Positive charges.
Positive charges move in direction. So it is positive 6i. Is it clear? It's
Yes,
positive 6i. Then
Sir, can
Uh,
you explain the positive charge moving direction means?
direction of current is positive charge moving direction. Am I correct?
Yeah.
If we are considering the direction of the current, it means we are following the direction of positive charge moving direction. Am I correct? Is it clear to the Nipun?
Yeah. Yeah.
So when I'm considering this direction, that is positive charges move in direction. In another terms, the direction of current. Am I correct? The direction of current. So I'm considering the direction of current. Because of that, that means positive charges move in direction. Because of that, we can say it's positive 6i. Is it clear or not?
It's
Clear
clear,
then
sir.
what? Okay. Now I'm going to second one. There
Yeah,
is another
it's-
resistor. There is another resistor. Are we moving into the current moving direction or opposite direction? Through this 2 ohm resistor. Are we moving to the? Yeah, it's current moving direction. So is it positive or negative?
Positive.
Positive. Then positive 2i. Is it clear or not?
Clear.
Okay. Then there are no any other resistance. So I have to simplify this term. Okay. It's 16. 16 is equal 6 plus 2, 8i. So I is equal to amperes. Is it clear for everyone? No? Any other doubts? Is it easy? Is this concept is easy? Because my concept is little bit different from what in your book. Because I am using a short form to calculating the current of the current of each circuit diagrams. Okay. So I'm using the same theory, but in different way. Is it easy for you or ඒක ඔයගලන්ට තේරුණාද නැද්ද? ඒක ලේසිද ඔයාලට?
Yes, sir.
Okay. Then please note down these things. Then I will give you another one. There are a lot of questions. I will show you. Please do this one. Please do this one. Yes. Please do this one and tell me what is the current through the circuit. Calculate and tell me. Okay. Now I'm going to, someone says 1 ampere. I don't know how do they get 1 ampere. So I will do it again. Please go through my concept. It will be easy to you. Okay. This is the question. There is 2 ohm resistor in here and 10 volt cell in here. 3 ohm, 5 ohm and 20 volts. When we are doing these type of questions, first you have to go through step by step. Otherwise, you will be get wrong. Okay. Then I will draw. This one is 20 volt and this one is 10 volt. I think this one is 2 ohm and this one is 3 ohm. This one is 5 ohms. First, I am going to mark the current from larger cell, that is 20 volt. So current is starting from here, then I, then I, then I. Now I'm going to mark the loop. It's A, B, C, D. Then I have to consider a direction. I will do it in this way. Same direction current passing. Okay. Then I'm starting from D point. D, A, B, C, D. I'm applying Kirchhoff's second law. Sigma E is equal sigma ER. From starting from D, first I am getting security job, then I am getting principal job. It is promotion. Then positive 20. Then I am moving in this direction. There is no EMFs, and there is another one. First I am got security, then I got principal job. Is it a promotion or demotion?
Promotion.
Yes, it's promotion. So I have to put positive 10 volts or negative 10 volts?
Positive 10 volt.
Positive 10 volts. Then there is no other cells. So I'm going to find out the sigma ER value. I'm starting from D again. There is a 5 ohm and current is, we are considered the direction of the current. So it's positive 5I plus direction of current. So positive 2I and direction of current, it's positive 3I. It's 30 and this one is 10 I. I is equal 3. Is it clear for everyone? There is some students send me 1 ampere current. That Hansani and Disara. Are they clear about this one? ඔයාලට clear ද මේ Hansaniටයි Disaraටයි clear ද මේ concept එක? මට එවල තිබුණා 1 ampere කියලා. මේක තේරුණාද? Hansani? Disara? Okay. හරිද? I will do another example. This one. There is 3 ohm resistor in here. 5-volt battery in here. And 15-volt cell in here. Please do it and tell me what is the answer. So I will discuss this one again. First, I have to start from larger cell. This is a larger cell. This one is I, 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 I. So I'm going to mark this one A, B, C, D. Now I have to consider a direction. Now I'm going to consider this direction. Okay. For change, I will take this direction because all of them got the answer now. So I will do it in this direction and shall we check this direction also given the same answer. Okay. Now I'm starting from, tell me a point A, D, C or B. Nipun? කොහෙන්ද පටන් ගන්න? A, D, C, B, A, C. Any point?
So let's start with B.
Okay. Then let's start at B and I'm going to the counter clock direction. Okay. Or anti-clockwise. So I'm going to applying Kirchhoff law to the BA-DCB loop. BA-DCB loop. And this is my direction. Okay. Now I'm starting from 5. Sigma E is equal to sigma IR. Then I'm starting from B. And first I got security job or principal job. First I got security job or principal job. When I'm starting from B and moving to this direction. Security job or principal job?
Security job.
It's security job. And moving to the principal job or security job?
Principal.
Principal job. Is it positive or negative?
Positive.
It's positive 5. Then I'm moving to the principal job and then I got security job. Is it demotion or promotion?
Demotion.
Demotion. Is it negative or positive?
Negative.
It's negative 15. So that's all for the batteries. Now I'm starting from and starting again from B and moving this direction. Through the 2 ohm resistor, the direction of current is this direction. Am I correct? Am I correct? The direction of positive ion moving is this direction. Is it clear?
Yeah.
Yeah. Then I'm considering the direction of the positive ion moving the direction or negative ion moving direction. I'm going in this way.
Negative moving direction.
Negative moving direction. Is it a negative 2i or positive 2i?
Negative 2i.
So is negative 2i. Then again, am I considering the positive ions or negative ion moving direction through the 3 ohm resistor?
Negative.
Negative. So plus negative 3i. In this case, I'm getting the minus 10 and this one is I'm getting minus 5i. Then I is equal positive 2 amperes. Is it clear or not?
Clear.
Clear the මේක හැමෝටම? නිබුන් මේක clear ද නැද්ද ඔයාලට?
Yes.
Yes, I clear.
Okay. Then I'm going to moving a little bit harder one. Okay. Now I'm going to moving a circuit like this. So can anyone tell me how many loops are in this circuit?
3 loops, sir.
3 loops.
Yes, it has 3 loops. Now, first I am going to mark the current through this circuit. First, I have to start from largest cell. Okay, it is 10 volt, and it is the only one cell, only cell in this circuit. So I'm starting from 10, and there is simple I current passing from here. Then now we got a junction. Now what happened at this junction? The current is divided in 2 ways. Okay, I'm considering the part of the current which is flowing through this 3 ohm is X. Another one we can say I minus X. Is it clear or not?
Yes,
Clear.
Okay, then this one is X, and this one is also X, and this one is X. This one is I minus X. I minus X. Now, when we getting sum of the I minus X and X, it's again I and I. Okay. Now I'm going to mark the points. A, B, C, D, E, F. Okay. Now we have to calculate 2 unknowns. For that, you know, in your grade 10 knowledge, you have to take 2 simultaneous equation for calculating the value of 2 unknowns. Am I correct?
Yeah.
So for getting 2 simultaneous equation, we have to consider separate 2 loops. So for this time, I am going to applying all 3 loops. I'm going to applying the Kirchhoff second law to the all 3 loops. For your knowledge, okay, how do we apply the Kirchhoff law to every loop? Okay, first I am going to consider this loop. That one is E B C D E. E B C D E. This loop. Okay. Now I'm going to applying Kirchhoff second law to this loop. First, we have to identify the loop. E B C D E, and the direction of the current, direction of the considered direction. And now I'm going to applying sigma E is equal sigma R. When I'm going to applying sigma E is equal sigma R, I'm starting from simple E, capital E. Then there is no EMF values, and there is a 1. I'm going to security to the principal, so it's positive 10. So positive 10 is equal. There is no any other cells. So I'm starting from E again, and this one is 2 positive 2y plus, and this one is positive 3i. So 3x. This is my first simultaneous equation. Is it clear for everyone?
yes,
Yes, sir.
Okay. Now I'm going to applying Kirchhoff law for this loop. That means I'm going to apply it in EBAFE. EBAF and E. The direction is this direction. Sigma E is equal sigma R. So I'm starting from E, and this positive to negative. That means security to principal. It is also positive 10, and there is no any other batteries. So I'm again come to the E position, and this one is 2y, and this part is plus 4 times I minus X. I can simplify it more. So 2y plus 4y minus 4x. So this equation can be taken as 6i minus 4x. You can simplify it further, but I'm not going to simplify it. Okay, I will take it like this. This is the second equation. For your knowledge, I'm going to apply Kirchhoff law to the third loop also. You can consider any direction, either this direction or this direction. Okay. Now I'm going to applying Kirchhoff law to this
Sir,
direction.
which
Sorry.
is third? Which is third loop? Can you show it? Let's see.
Yeah, I will
Bigger
show
one.
it. This one. This is the third loop. Starting from here. This is the third loop. Am I correct? There is also a loop.
But
It is closed loop, and there is no cell. That's that is not a problem. Cell is not compulsory. Okay. If there is cell, you have to apply the theory. But if there is no any cell, you can do it in other way. Okay. So I will take clockwise. So I think I will take this one, this direction, anti-clockwise direction. Okay. Now I'm applying to Kirchhoff law to the A, F, E, D, C, B, and A. To anti-clockwise direction. So sigma E is equal sigma ER. Now, I will start from A. When we are considering 4 ohms, I'm considered the direction of the current. Sorry. First of all, we have to consider the EMFs of this loop. So when I'm starting from A, there is no cells, no cells, no cells, and no cells. So EMF is 0. Is it clear? Is it clear or not? When I'm starting from A, there is no cells in this part, and there is no cells in this part from F to D. There is no cells in this part from D to C. There is no cells in this part, C to A. So there are no any EMFs. Because of that, sigma E is 0. Is it clear? Is it clear or
Yes,
not?
sir.
Okay. Now
Yes,
I'm
sir.
going to applying other part, the production part. Now starting from A, when we are considering the 4 ohm, I'm considering the direction of current. Because of that, it's positive 4I minus 6 plus. When we come to the upper part of the loop, that means 3 ohm resistor, our direction is this one, but the current flowing direction is opposite one. Because of that, we have to say it's negative 3x. So negative 3x. It is nothing to do. It is nothing to do with the direction. Actually, the negative and the positive means that type of the charges which are flowing to that direction. Okay. It is not a type of that direction thing in the vector, because current is not a vector. Okay. Current is a scalar quantity. It does not have a specific direction. This is negative and positive means the type of the charges which are flowing to that direction. This negative means to that direction, negative charges are flowing. It's positive means to that that considered direction, positive charges are flowing. Is it clear? Is it clear for everyone? එක clear ද හැමෝටම? මේකේ direction එකක් නෑ මේ current එකට. හරිද? current එක direction එකක් තියෙන එකක් නෙමෙයි. current එක අදිශයක්. දෛශිකයක් නෙමෙයි. එතකොට current එකට specific direction, ඒ කියන්නේ direction එකක් නෑ යාට. මේ අපි ඍණයි ධනයි කියලා දාන්නේ ඒ පැත්තට ධන ආරෝපණ නම් යන්නේ. එතකොට අපිට ආරෝපණය කියන්න වෙන්නේ sorry ධාරාව කියන්නේ ධන 10 කූලෝම් තප්පරයට කියලානේ. එතකොට අනිත් පැත්තට ඍණ 10 කරනවා නම් අපිට කියන්නේ ඍණ 10 කූලෝම් තප්පරයට කියලානේ. එතකොට මේ ඍණ ධන කියන්නේ මේ දිශාව නෙමෙයි, ඒ ආරෝපණ වර්ගය. ධන ආරෝපණ නම් ධන, ඍණ ආරෝපණ ඍණ. ක්ලියර්ද කියන එක? තේරුණාද නැද්ද ඒක? Is it clear for everyone?
Yes, sir.
Okay. Now I'm going to simplify this one also. 0 is equal 4i minus 4x minus 3x. So we can take another equation. 0 is equal 4i minus 7x. Okay. Now there is 3 simultaneous equation, but we need to calculate only I and x, no? So we have to consider any two. You don't have to take all three. In this case, I'm taking this one because I have to show you how to applying Kirchhoff law to the that big loop also. Is it clear for everyone or any other questions? Anyone? කාට හරි ප්‍රශ්න තියෙනවා නම් අහන්නකෝ. ප්‍රශ්න මොනවද තියෙනවද කාට හරි?
Sir,
ඔව්.
I am not so clear about the marking of currents, like the direction and all, sir.
It's simple. When I'm considering this direction, if current is also passing through that direction, if I'm considering this direction, that means I'm going to this direction also. No, is it clear?
Yes, sir.
So current is also passing through that direction. No,
Yes, sir.
then it is positive. Clear?
Okay, sir.
If we are considering this direction, if we
Excuse
take
me,
this,
sir.
yeah,
So that means if we consider A, F, E, B, A, the
AFED
below one,
or anything,
yeah,
anything. If
if
you are
then
considering this direction,
yeah, if the current pass through that considered direction, the current is positive.
no, we have to tell it like this. We have considered the direction of current it is positive. Same thing.
Okay.
Okay.
That means yeah, if the current pass through A, B, E, F, A, that then it is negative.
A B E F A.
Yeah,
If
the
we are
reverse direction.
considering this direction and current is going to the opposite direction, it's negative.
Yeah. Okay.
Is it clear?
Yes, sir. Thank you.
Is it clear for the other one also? I don't know who is asking that one.
Yes, sir. Clear, sir.
Okay. Then now I'm going to applying.
Excuse me, sir.
Yeah.
Actually, in those cases, we have no idea what the current flow
Yeah,
really is, but
yes.
we assume in the directions are
Yeah.
on the-
If your considered direction is wrong, your answer will get negative. That means your marked direction is the negative and flowing direction.
Okay, sir, got it.
Okay. Now I'm going to applying the simultaneous equation. You can be easily solve it in your calculator. It is different from calculator to calculator according to what is the model of that one. So if I'm taking this one and this one. Okay, it is easy to me. So 2i and 3x is equal to 10. Then 6i and minus 4 is equal to 10. So value of I is 2.692 amperes and value of x is 1.538 amperes. Okay, you can also calculate I minus x from this one. Okay, is it clear? Is it clear for everyone? No, not.
Yeah.
එක clearද නැද්ද හැමෝටම? එක clearද හැමෝටම?
Yeah,
Yes,
it's
sir.
clear, sir.
Okay. I will give you. There are a lot of questions. Okay, I will show you. There are a lot of questions. This is a question I have done earlier, and there is a lot and other questions in the slides also. Okay, you can go through it and calculate each one. Okay, I will give you this one. Calculate the current of this one. Calculate it. This one. මම මේක සිංහලෙන් එක්ස්ප්ලেইন කරන්න ඉල්ලපු නිසා හරිද බලාගන්න පළවෙනිටම කරන්ට් එක මාක් කරනකොට වැඩිම EMF එක තියෙන සෙල් එකෙන් පටන් ගන්න. ඒක රූල් එකක් නෙමෙයි. ඒක ඔයාලට හුඟක් වෙලාවට ලේසි වෙයි. තේරෙනවද කියන එක? වැඩිම EMF එක තියෙන එකෙන් පටන් ගන්න. එහෙම පටන් ගත්තොත් මට පටන් ගන්න පුළුවන් මේ විදිහට තැනකින් පටන් ගමුකෝ. 8 වෝල්ට් කින් පටන් ගන්නෙ. I කියලා කරන්ට් එකක් එනවා. හරිද ඊළඟ? එතකොට අපිට මේක පළවෙනිටම හම්බෙන්නේ මේ හන්දියා. මේ ජංක්ෂන් එකනේ හම්බෙන්නේ. මේ ජංක්ෂන් එකෙන් අපිට බලා ගන්න පුළුවන් මේක පැත්ත දෙකකට කැඩෙනවා. එතකොට මම මාක් කරගන්නවා මේ පැත්තට යන කරන්ට් එක I-x කියලා මාක් කරගන්නම්. මේ පැත්තට x කරන්ට් එකක් යනවා නම්. ක්ලියර්ද කතාව? එතකොට මේකේ x මේකත් x මේකත් x මේකත් x. මෙතනින් ආවොත් I-x 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 මේක I. ක්ලියර්ද නැද්ද? සිංහලෙන් පැහැදිලි කරන්න කිව්ව අයට ක්ලියර්ද නැද්ද?
Yes, sir.
ඕකේ. දැන් ඔයා පළවෙනිටම මේක මාක් කරගන්න ABCD විදිහට. මම මේක මාක් කරගන්නවා A B C D E F. හරිද? දැන් මෙතන ලූප්ස් කීයක් තියෙනවද ඊළඟ? sorry. ලූප්ස් කීයක් තියෙනවද මෙතන? ඊළඟ මෙතන ලූප්ස් කීයක් තියෙනවද? ඔයාලට ඇහෙනවද මාව?
Oh, එහෙනම්
ලූප්ස් කීයක් තියෙනවද මෙතන? චක්‍ර කීයක් තියෙනවද මෙතන? සංවෘත
දෙකයි.
පුඩු. මෙතන තුනක්
දෙකයි.
තියෙනවා චක්‍ර. සංවෘත පුඩු තුනක් තියෙනවා. මේ තියෙන්නේ එකයි. මේ මම මාක් කරන්නේ එක. හරිද? ක්ලියර්ද ඊළඟට?
Oh, sir.
මේක දෙක. ක්ලියර්ද කියන්නේ?
Oh, sir.
මේ තියෙන්නේ තුන. ක්ලියර්ද නැද්ද?
Oh, yes, sir.
එතකොට චක්‍ර තුනක් තියෙනවා කියලා තේරෙනවද කියන්නේ?
Oh, sir.
හරි. එහෙනම් ඔයාලට මේකෙන් හොයාගන්න තියෙන x y i විතරනේ. එතකොට ඔයා ඕනම චක්‍ර දෙකකට මේක ඇප්ලයි කරන්න. ක්ලියර්ද කියන්නේ? කියන්නේ
Oh, sir.
ඔයගේ හරි. ඇප්ලයි කරන්න මට මේ චක්‍ර දෙකක් කියන්නකෝ. නම් කරන්න මේ ABCD ඇසුරෙන් ඔයාලට නම් කරන්න පුළුවන්.
B, E, D, E,
sorry. B
B, C, D, E, B,
කොතනින්ද
B,
පටන්
C,
ගන්නේ? B ගෙන්ද E ගෙන්ද A ගෙන්ද මොකෙන්ද පටන් ගන්නේ?
B again, sir.
B එකෙන්. B
E, D, E,
B C D E.
B.
හරි. මම ඒ කියන්නේ මේ ඩිරෙක්ෂන් එකයි කන්සිඩර් කරේ මං හරිද?
ඔව් සර්.
එහෙනම් මම BC DE B කියන ඩිරෙක්ෂන් එකට ඇප්ලයි කරන්න යන්නේ Kirchhoff seconds law. ඒ කියන්නේ මේ ඩිරෙක්ෂන් එක. මම ඇප්ලයි කරනවා sigma E is equal sigma ER. එතකොට මම E ගෙන් පටන් ගත්තොත් එහෙම ස්ටාර්ට් කරොත් එහෙම E ගෙන් ඉඳලා මෙතනට එනකොට මේ security principle ද? ඊළඟ
positive සර්.
මම අහන්නේ මේ කොට එක්කෙනා security principle ද කියලා.
security
security. එතකොට මේ ඉන්නේ කවුද? උස එක්කෙනා principal security ද?
principal
principal. එතකොට security ඉඳලා principal ට යනවා නම් positive ද negative ද?
positive සර්.
positive. එහෙනම් positive 8. ඒ loop එකට වෙන batteries තියනවද?
නෑ සර්.
නෑ. ආයි පටන් ගමු E ගෙන්. E ගෙන් ඉඳලා යනවා. 3 ohm resistor එක ගත්තාම අපි consider කරපු direction එක මේකනේ. ඒ direction එකම කරන්ට් එක යන්නේ අනිත් පැත්තටද?
ඒ direction එක
ඒ direction එකටම නම් යන්නේ positive ද negative ද?
positive සර්.
positive. එහෙනම් positive 3i. ඊට පස්සේ මම එහෙම එනකොට 5 ohm ට අපි consider කරපු direction එකටම කරන්ට් එක යන්නේ නැත්නම් opposite direction එකටද?
නෑ සර්.
අපි ගත්තු direction එකටම. ඒ පැත්තටමයි. හරි. එහෙනම් positive 5i minus x. මං හරිද? එහෙනම් මට මේක ලියන්න පුළුවන් 8 is equal 3i plus 5i minus 5x කියලා. හරිද? 8 is equal 8i minus 5x. මේක first equation. තේරුණාද නැද්ද?
තේරුණා සර්.
දෙවෙනි එක කියන්න loop එකක් තව.
EB EF
okay. EBAFE. AFE. එතකොට consider කරපු direction එක මේක. apply කරනවා sigma E is equal sigma ER. sigma E ගත්තාම E ගෙන් පටන් ගමු අපි. හරිද? security to principal ද principal to security ද?
security to principal
එහෙනම් positive ද negative ද?
positive
positive 8. ආයි යනකොට principal to security ද security to principal ද?
security to principal
එතකොට
Positive.
positive. වෙන batteries නැහැනේ. ඊට පස්සේ ආපහු සෙටක් E ගෙන් පටන් ගමු. E ගෙන් ඉඳලා යන්න. 3 ohm resistor එක තියෙනවා. අපි ඇවිදන් යන්නේ කරන්ට් එක යන පැත්තටමද නැත්නම් අනිත් පැත්තටද?
current එක යන පැත්ත
එහෙනම් positive ද negative ද?
positive සර්.
positive. එහෙනම් 3i. ඊට පස්සේ අපි ඇවිදන් යන්නේ කරන්ට් එක යන පැත්තටමද අනිත් පැත්තටද?
current එක යන පැත්තටමයි
යන පැත්තටම. එහෙනම් positive ද negative ද?
positive සර්.
positive 2x. clear ද? එහෙනම් මට එනවා 8 plus 4 12 3i plus 2x. දැන් ඔයාලට පුළුවන් මේක දාන්න ඔයාලගේ calculator එකේ ඇති simultaneous equation වෙනම. මම දන්නේ එක එක models වලින් models වලට ඒක වෙනස් වෙනවා. ඔයාලගේ calculator එකේ model එක අනුව තමයි ඒකේ ඒක use කරන විදිහ තීරණය වෙන්නේ. ඔයාලා simultaneous equation simplify කරන්න දන්නේ නැත්නම් ওই calculator එකෙන් ඔයාලා YouTube හරි tutorial එකක් බලන්න. මම හැම calculator එකකම simultaneous equation පාවිච්චි කරන්න දන්නේ නැහැ. මගේ එකේ විතරයි දන්නේ. මගේ මොඩල් එක 991EX FX 991EX මොඩල් එක තියෙන්නේ. ඒක නම් ඔයාලට තියෙන්නේ setup එක ඔබලා setup කියලා එකක් ඇති. setup එක ඔබලා alpha ඔබලා එතන capital ඒ කියන්නේ රතු පාටින් capital A එකක් මාක් කරලා ඇති. ඒක ඔබන්න. එතකොට ඔයාලා simultaneous equation උයි polynomial equation කියලා 1 2 කියලා එනවා. ඒකෙන් එක ඔබන්න simultaneous equation. එතකොට unknowns කීයක්ද කියලා එනවා. unknowns මෙතන හැටියට අපි 2යිනේ පාවිච්චි කරන්නේ. එතකොට 2යි කියලා දෙන්න. එතකොට එනවා. අනිත් ඒවා නම් දන්නේ නැහැ. ES වල කොහොමද අනිත් calculators වල කොයි වගේද වැඩ කරන්නේ කියලා ES plus එකකුත් තියෙනවා. ඒවා කොහොමද වැඩ කරන්නේ කියලා දන්නේ නැහැ. වෙන brands නම් කොහොමද දන්නේ නැහැ මම. FX 991 EX එක පාවිච්චි වෙන විදියයි කිව්වේ Casio එකේ. හරිනේ. ඕකේ. මම දැන් දිලංක කරන්නේ මේ values ටික apply කරනවා ඔයාගේ calculator එකේ තියෙන values වලට. okay එතකොට 8i minus 5x is equal to 8. ඊළඟ equation එක අපිට එන්නේ 3i plus 2x is equal to 12. එතකොට අපිට i value එක එනවා 2.45. x value එක එනවා 2.32. හරිද? okay මේක clear ද හැමෝටම? දැන් තේරිච්ච නැති අයට clear වුණාද ඒක නැද්ද? තාම ප්‍රශ්න තියෙන අය තුසන්. if you have any doubts please raise your hand or දිලංක ඔයාට clear ද?
Okay, sir.
හරි
Okay, okay, okay.
අනිත් අයට clear ද? නිපුන් එයාලට clear ද? නිපුන් ඔයාලට clear ද?
ඔව් සර් ඒක ක්ලියර්.
okay හැදුවද ඒක? answer එක ආවද? everybody got the answer for that one?
ඔව් සර් ක්ලියර්. ඔව් සර්.
හැමෝම answer එක
ආවා සර්.
ආවා? 2.45. okay now I am moving to
ඒ උත්තරේ මාව සර්.
okay um, we did only this one and this one this one and this one. You have to go through these questions, then you will get proper training or proper practice before the examination. okay now moving to the another type. okay this is another type. In this case you will see there is a small difference in this question. In this case I'm taking this one is 3 ohm and this cell is 20 volt. The cell has 20 volt EMF, but there is 2 ohm internal resistance. Is it clear? okay now how we are going to solve this type of question? First I'm going to pull out this internal resistance into the out of the cell. okay pull this 2 ohm resistance out of this cell from any side. okay either this direction or if you want you can pull it out in this direction also, any side. Don't pull it out in both direction. okay it's not happening. Now this one is 20 volt and this is the 2 ohm internal resistance and this is 3 ohm. Is it clear? මේක තේරුණාද කියන්නකො මේක මම පාවිච්චි කරපු විදිය. මම මේකේ 20 ohm 20 volt resistor 20 volt cell එක ඇතුලේ තියෙන 2 ohm resistor එක එළියට අදගත්තා. දැන් මේ තමයි අර කලින් තිබිච්ච සම්පූර්ණ කෑල්ලම මම මේ විදියට අඳගත්තා. ක්ලියර්ද නැද්ද?
Clear.
okay
ක්ලියර් සර්.
now I'm going to mark again A B C D and do the question in similar way. okay now I will mark it in this way: A B C and D. I should have to mark the current also. This is I, 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 and I. Okay. Sigma E is equal sigma ER. Now I'm going to start from A, going to applying Kirchhoff's second law to ABCDA loop in this direction. Sigma E, I'm starting from A. First I got security job, then I got promoted to the principal job. That means positive 20 volts. Then I will start again from A. And when we are considering 2 ohm resistor, I'm considering the direction of current. Because of that, it is positive 2I. And this is also the direction of current. And this is also positive 3I. Then 20 is equal 5I. Then I is equal 4 amps. Is it clear? Make clear the හැමෝටම නැද්ද?
Yeah.
Okay. ඕක mark කරලා please mark it and do this question. 7, 8, 12, 3. Okay, do this one and tell me the answer. Okay, now I'm going to calculate this part. So when we are considering this part, okay, I will do it again. When we are considering this part, I'm not going to pull it out. What I'm going to do is, when we are considering the sigma E part, when we are talking about sigma E part, I'm only considering about 12 volts. When I'm going to talking about sigma ER part, I'm only going to consider about 3I. Okay, then I will start from A. It is 12 and it is security to the principal. It's positive 12. And again, there is 8 volt. It's positive to, it's negative to positive. That means security to the principal. It is also 8. And when we are considering sigma ER part, starting from A, there is 3 ohm resistor. I'm not going to consider about 12 volt at that time. I'm only consider about 3 ohm. So it is 3I. And then I'm going to this part. It is also 7I, positive 7I. I'm not going to talking about how that one is getting positive or negative, because I have already go through that one. 12 plus 8, it is 20. And 7 plus 3, it is 10I. So I is equal 2 amperes. Is it clear for everyone? Is it clear or not? I think
Yes,
lot,
sir.
yes, most of you got the answer. So there are a lot of questions about that. I'm doing only this question and this question. I did only this one and this one. You have to go through this question and train it, okay? It is not compulsory. If you would like to train more practice, you can go through that all things. Okay, then you will get better idea about that one. Are there any questions?
No, sir.
Can you please share the other questions, sir? I will send those slides into your chat. I think I will send it to you. Send it to Prabhat sir and also Nana miss. They will share it with you. Okay. I will send it today night or tomorrow morning. Okay. Then I'm going to talking about another question. It's like this. Two ohm, 4 ohm, and 1 ohm, 2 ohm. There is 1 ohm resistor. It is 6-volt cell. Okay. Please do that and tell me the answer. What is the answer? Please do it and tell me the answer. I think most of you get the answer. So I will do it. Okay. Now, first I'm going to mark it as A, B, C, D. It's A, B, C, C, D, E, and F. Okay. Then I'm going to mark the current. So first, there is simple I current, I, and from this point, it is divided into two parts. I'm going to consider this part as X and this part as I minus X. When I minus X is coming to this point, there is two ways, so it is also divided into two parts. This one is Y and this one is I minus X minus Y. And this one is Y, this one is X, and this part is X plus Y. This part is also X plus Y. Then I minus X minus Y plus X plus Y is again I. Is it clear for you? Is it clear or not? මේක තේරුණාද හැමෝටම මේකේ කරන්ට් එක මාක් කරපු විදිහ? මේකේ කරන්ට් එක මාක් කරපු විදිහ හැමෝටම තේරුණාද නැද්ද?
Understood.
Okay. So now I'm going to apply to the Kirchhoff law. We have to calculate three unknowns. Because of that, I have to take three simultaneous equation. First, I would like to show you what are the loops in this circuit. Okay, there is a one loop in this way. This is a loop number 1, and this is loop number 2. Okay, and this one is loop number 3. And this one is loop number 4. And this one is loop number 5. And this one is loop number 6. And this one is loop number 7. According to me, there is 7 loops. Are there any loops? Okay. I'm going to taking a three of them. First, I'm going to considering this loop. I think it is easy to me. I'm going to considering this loop. Okay, that means A, B, C, D, E, A. So I'm going to applying A, B, C, D, E, A loop in this direction. Sigma E is equal sigma R. Okay, E is 6. The only cell is 6. And then positive 2i minus 6 plus 4i minus x minus y. That means 6 is equal to 2i minus 2x plus 4i minus 4x minus 4y. Okay, then 6 is equal 8i minus 6x minus 4y. I'm not going to simplify further. I'll take it like this. And then I'm going to apply Kirchhoff law to this part. When considering that one, A, B, F, D, E, A, B, F, D, E, A.
Excuse me, sir. It is 8i or 6i?
This one is
It is 6i.
which one? This is 2 and
The
yes,
last
this
answer.
one is 6. This one is 6. Sorry. This one is 6i. 2i and 4i. Yes, then this one is also 6i. X and this one is minus 4y. Yes, thank you for that. Okay, if I am applying this loop, it's A, B, F, D, E, A. So sigma E is equal sigma R. Sigma E is 6 and this one is 1x plus 2x plus y. Then 6 is equal 1x plus 2x plus 2y. Then 6 is equal 3x plus 2y. And this one is 2. And we have to consider another one. Okay. I'm going to consider this loop. This loop, okay. If I am considering that loop, if I am applying sigma E is equal sigma IR to that loop, okay, it's F. I'm going to consider it as FBCF loop. This is FBCF in this direction. Sigma is there is no electromotive forces and in that loop, so it is 0. Then I'm considering this direction, so this one is positive 2i minus 6 and this part is I'm considering this direction, but current is flowing to the opposite direction because of that minus 1x. So 0 is equal 2i minus 3x. This is the third equation. Okay. Now you have to simplify the simultaneous equations. Now then you will find out this I minus x value is this I minus x value is equal to the 1 amperes and x is equal to the 2 amperes and I is equal to the 3 amperes and y is equal to the 0 amperes. There is a special case in this question. You can see in this type of question, you can solve it easily by using Wheatstone-Bridge concept. What is Wheatstone-Bridge concept? If you are getting a circuit like this, and the ratio between these two, 2 ohm and 4 ohm, is equal to the ratio between these two, 1 ohm and 2 ohm, we can say the current which is passing through a middle resistor, which is considered at 1 ohm, is equal to the 0. This is happens only when this ratio is equal to this ratio. Okay. That means in another terms, if circuit like this, this one is R1 and this one is R2, this one is R3, this one is R4. R1 R2 ratio. If R1 R2 ratio is equal to R3 R4 ratio, we can draw it like this. Only like this. The shape is not compulsory. It can be like this also. This one is also correct. This is also like this. Okay. If some circuit shows that this relationship, which is called as Wheatstone-Bridge relation, we can draw it in this way. Okay. This is all about Wheatstone-Bridge relation. Is it clear for everyone?
Excuse me, sir.
Yeah.
If we can say R1 R3
Yes.
ratio
Yes.
equal
Yes.
to R2
It is
ratio.
also correct. That means if you asking this one, if you take this one into here and this one goes to here, that means R1 over R3 is equal to the R2 over R4. It is also correct. It is also the version of this one. The simple mathematics, no? Sorry. Is it clear for that student? Is clear?
Yes, yes.
Okay. And now, that's all about Kirchhoff's law. But you have a lot of questions in here. There is some questions which is following the Wheatstone law. Some others just not following the Wheatstone bridge. So go through this part and calculate it. Don't do this part, okay? Don't do this part. It is a little bit of complex to you. I think I will clear it and send you. There is another way to calculating the. Okay. Shall I continue it up to equivalent resistance, or shall I wind it from here? Wind up the session from here. Do I need to go through the equivalent resistance also?
Yes, sir.
Okay. I will go to the equivalent resistance part also. Quickly, I will go through that one. Some part I have already discussed in previous session. I think a lot of people are not, lot of people were not in that meeting. So I think I have already sent the, I'm not in your group, but I think my other partner is,
So was it conducted by you or
yes, I did conduct. But lot of people
when? What was the date?
last Saturday.
27.
I don't know. There is only 5 or 7 people.
We had
That is least participants I have got ever.
chemistry exam, sir.
Sorry, sorry.
We had
Next
exam
day we had a chemistry exam.
Ah, actually, I don't know about that one. They are asking me to schedule a 2 day schools. I'm also having cat in this week, no. So I said them I can do it in 3rd of Saturday and 10th of Saturday. So they scheduled and send it into the timetable is send it into your chat. So I was thinking you all are okay with that. Is it organic chemistry? Exam.
Electro and
Electrochemistry and thermodynamics.
That means basic principle chemistry 2. Am I correct?
Yes, sir.
Okay. We will continue this part also. Quickly, I will go through that one.
So can
My
we get the recording of that session?
I have already sent it. Actually, I don't have any contact of yours because I'm not in your group also. I would not like to join the group. Okay. So I think my other one is, I think Prabhat is in that group, not the Prabhat sir. I think there is another sim named Prabhat. He sent it into your chat. He told me he sent it. And I have already sent it into the Prabhat sir and also Nainamis. I don't know whether you got it or not. Actually, in last session, I did how to calculate thermal group. Okay, I did not upload into the thermal group. Actually, it is also uploaded by someone. I don't know who is that. I saw it. I was in thermal group. And now I am also is in thermal group. Am I? Yeah. I'm in thermal group. Are there any group for the electromagnetism also? I don't know. There is a separate group for the electromagnetism. Basic
Yes,
electromagnetism.
sir.
Yes.
Yes, sir.
So I'm not in that group. Anyway, shall I continue up to equivalent resistance, ending of the equivalent resistance? Okay.
Yes, sir.
Okay.
Let's go.
Yes, sir.
There is lot of questions. You have to practice them. Okay. Otherwise,
Sir, what was the discuss about last past session?
in last past session, I was discussed about simply discuss about the current and how to calculate the potential in the point in the circuit. There is a concept like this, the simple concept like this. Go through it and go through it. I think it will understandable for you. It's easy. It is also a concept, what I call it's Ayamalli concept. You can go it and check it. Okay. For which one? Can you send the link? For what link? So attendance link. I don't know. Okay, I will send the attendance link. This is the attendance link. Okay. I don't know which link. Okay. First, I will go through the seriously connected resistor system. Okay. If you are consider a resistor systems which is connected in series, there is R1, R2, and R3, and many other resistance also up to Rn. Okay. Now I have to calculate what is the equivalent resistance of these systems. Can you tell me what is the mean by equivalent resistance? What do you mean by equivalent resistance? සමග ප්‍රතිරෝධය කියන්නේ මොකද්ද? Equivalent resistance කියන්නේ සමග ප්‍රතිරෝධය සිංහලෙන්.
ඔය ප්‍රතිරෝධ වෙනුවට යොදන්න පුළුවන් තනි ප්‍රතිරෝධය.
අන්න හරි. The single resistance which can represent the complete resistor system. Okay. Or in another terms, a single resistor which can replace this whole resistor system. Is it clear? That means if I am connecting this resistor system into some voltage, if I am considering there is I current pulled by this resistor system, equivalent resistance must be pulled I current by itself. Am I correct? If it is equivalent resistance is Re, it should be also pulled out I current from voltage source by itself. That means the current which pulled by all resistance from this resistor systems is pulled by Re alone. Am I correct? Is it clear? ඒ කියන්නේ Re කියන resistor එක තනියෙන් අදින්න ඕනේ මේ මුළු system එකම ඇදපු current එකම. මං හරිද ඒ voltage source එකටම ගැහුවාම. Is it clear for you? ඒක clear ද නැද්ද හැමෝටම?
Yes, sir.
Okay. Now you have to remember one thing. If there is no item, what I'm talking about, talking as item means either resistor or cell or capacitor. Okay. If there is no item, the voltage is not changing. Okay. When I'm considering this part is positive side and this part is negative, I will draw it in blue color. And up to this position, it is red because it is in same voltage. Am I correct? It has same voltage value up to this point. මේක clear ද නැද්ද හැමෝටම? මේ මං කියපු කතාව. item එකක් හම්බ වෙන තාක්කල් ඒ voltage එක constantly තියෙනවා. පැහැදිලිද කීප එක නැද්ද? I have already
Can
discussed it. Sorry.
you explain it again, sir?
Okay. If there is no resistance or capacitor or cell, the voltage will not change. Will not be changed. Clear the keep එක. ඒ කියන්නේ voltage එක change වෙන්නේ නැහැ. කිසිම resistor එකක් හෝ capacitor එකක් හම්බ වෙනකන්. Clear the keep එක නැද්ද? Is it clear or not?
Oh, okay.
Okay. Then you can see there is a resistor. So no longer that voltage is in red color one. Okay. It's changing and there is another voltage. Am I correct? Up to this point, it has green color voltage. After the R2 voltage, it take another color. Okay. Up to this R3 voltage, it's like this. And after that one, it is not in same color. It is changing to blue. And up to this point, it is blue. Is it clear or not? ඒක clear ද නැද්ද? ඒක මම කියපු කතාව කියන්නේ.
Clear.
Okay. Now, what is the voltage difference in between red and green? Sorry, red and blue. What is the voltage difference in between red and blue? Can anyone tell me? කාට හරි කියන්න පුළුවන්ද රතු පාට නිල් පාට අතර voltage difference එක කීයද කියලා?
V.
Zero.
V.
V.
V. Then what is the voltage difference in between red and blue?
Same. V.
Same. V. Do we know what is the voltage difference in between red and green? Do we know? What is the voltage difference in between red and green?
Not that.
No, we don't know. It is considered as V1. Do we know what is the voltage difference in between green and yellow?
Two.
No. It is also considered as V2. Do we know what is the voltage difference in between yellow and blue? Do we know?
No.
No, it is V3. But we know that V1 plus V2 plus V3 should be equal to V. Am I correct? Is it clear or not? These voltages are this voltage summation of these voltages should be equal to the V. Am I correct? Is it clear to everyone? එක හැමෝටම තේරුණාද නැද්ද? ඒක
Clear,
clear
sir.
ද නැද්ද? Okay. Then if I am applying Ohm's law to this R1 resistor, if I am applying Ohm's law to R1 resistor, you can see there is simple I current passing through R1 resistor and voltage drop across the R1 resistor is V1. So when I'm applying V is equal IR to that one, we can say this V1 is equal to simple I into R1. Okay. Likewise, when we are applying Ohm's law to R2 resistor, V is equal IR, we can say V2 is equal I times R2. So if I'm applying R3 resistor, V3 is equal I into R3. Likewise, if there are any resistors also connected in series way, you can write like this. Am I correct? Is it clear or not? ඒක clear ද නැද්ද? ඒක clear ද නැද්ද?
Yes, sir.
Okay. Clear නැත්තම් කියන්න clear නැහැ කියලා කෙලින්ම. Okay. Now I'm going to applying uh, this concept to this circuit also. This is positive one and this one is negative. Now this is red color and this one is blue color. What is the voltage difference in between red and blue? It is V. Then this one is also V.
V.
If I am going to applying Ohm's law to this equation, this circuit, we can write V is equal IR. Then V is equal simple I into RE.
Equal.
Okay. Now I am going to substitute this equation into this first equation. Okay. If I am substitute that one, we can write it as IR1 plus IR2 plus IR3 plus if there are any other resistance also is equal to capital V can be written as IRE. Clear. I and I is cancel out. Then we can write it as RE is equal R1 plus R2 plus R3 plus. For the series connection, this is the equation. Is it clear or not? Make a clear the up with another.
Clear, sir.
Okay. There is something you should notice. In series connection, all the resistors have same current but different voltage. Same current and different voltage. And also, I have to show you another really important thing. If you are carefully go through this diagram, you can see if resistors are connected in seriously, you can see the colors of the both ends are not equal. Am I correct? One side is equal for two resistors, but the other sides are not equal. Am I correct or not? Are you notice that one? Did you notice? ඒක ඔයාලා notice කරගත්තද? ඒ කියන්නේ resistors එක series ලං connect කරලා තියෙන්නේ දෙපැත්තේ පාට අසමානයි. දැක්කද? මේ පැත්තේ තියෙන්නේ red and green. මේ පැත්තේ තියෙන්නේ green and yellow. මේ පැත්තේ තියෙන්නේ yellow and blue. දෙපැත්තේ පාටවල් සමාන නැහැ. Clear ද කියප එක නැද්ද? Is it clear or
Yeah.
not? Okay. Now that's all for the series connection. Now I'm going to the parallel connection of the resistors. If I'm connecting R1, R2, R3 resistors and any more resistors in parallel, R1, R2, R3, and there are more resistors. And same in previous case, I'm going to connect it into V voltage. What is mean by equivalent resistance? The single resistant which can represent the whole resistor systems, whole resistor system. Clear? Now this one is equivalent resistance. If this resistor systems pull out simple I current from the V source, this is should be also pulled I current from voltage source. Am I correct? Okay. In this case, you can see if I'm color it from red color in positive side, you can see up to resistor or cell or capacitor, you can color it in same color. This is same color, and same color. Did you notice that one? ඔයාලා ඒක දැක්කද? resistor එකක් හරි cell එකක් හරි එනකම් මම මේක එකම color එකකින් පාට කරේ. No. I cannot color this part as a red color because there is a resistor in between that parts. No? So this is negative part. If I am coloring the negative part, you can see up to some item, that means resistor, cell or capacitor, you can color it in this way. Okay, clear? I will do same thing for this circuit also. What is the voltage across red and blue? Can someone tell me? What is voltage across red and blue?
V.
V. What is voltage across red and blue?
V.
V. What is voltage across red and blue?
V.
V. And what is
Uh,
voltage
V.
across red and blue? Yes, it's. And current can be different. This one is I1. I will take this one is I1. This one is I2. And this one is I3. Likewise. Okay. But according to the Kirchhoff's first law, we know I should be equal to I1 plus I2
I2 plus
plus
I3.
I3 plus. If there are any other resistors, you can write it in this way. Okay. Now I'm going to applying again Ohm's law into each resistor separately. Okay. If I'm going to applying R1 Ohm's law into the R1 resistor, we can write it as like this way. V is equal IR. V is equal IR. So V is equal I1
I1
R1.
R1.
So I'm going to subject the I1. Then I can take it as I1 is equal V over R1. Likewise, I can take I2 as I2 is equal to V over R2. And I3 is also equal to V over R3.
R3.
If there are any other resistors which are connected in parallelly, you can write it like this. Okay. Now, if I am come to this part, can anyone tell me what is the voltage across red and blue?
V.
V. And voltage across red and blue?
It's also V.
It's also V. Now I'm going to applying Ohm's law to this resistor also. Now, if I'm going to applying Ohm's law to this resistor, V is equal IR. So we can write it as V is equal simple I into RE. Now I'm going to subject simple I. Simple I is equal V over RE. Is it clear or not?
Clear.
Now I'm going to substitute each value for the I1, I2, I3 and simple I to this equation. So if I'm applying those things into this equation, I is equal I1 plus
I2 plus.
I2 plus I3 plus.
Likewise.
Okay, simple I is equal V over RE. This one is V over R1 and this one is V over R2 and this one is V over R3. Likewise, we can write V to V to V to V is cancelled out. Then I can write it as 1 over RE is equal 1 over R1 plus 1 over R2 plus 1 over R3. This is equation for seriously connected resistor system. Okay. Now I will show you another important thing. In this kind of resistor connection, you can see each resistor has same voltage drop, same voltage difference. But different current. Different current through the each resistor. And also there is another important thing you should notice. If resistors are connected in parallel way, you can see colors of two end is equal, is same. Am I correct? Not like in series connection. In series connection, this R1 get red and green, R2 get green and yellow, R3 get yellow and blue. But in this case, you can see R1 got red and blue, R2 got red and blue, R3 got red and blue. Is it clear for everyone? It is really important point when you are calculating equivalent resistance. Okay. Is it clear or not? එක හැමෝටම clear ද නැද්ද?
Okay.
හැමෝටම එක තේරුණාද? හැමෝටම අනිත් අයට?
Clear.
Okay. Now I'm going to calculate equivalent resistance of some circuit. First, I will take this one. This one is 4 ohm and this one is 8 ohm. First, I'm going to check it out. Is it parallel or series connection? I know you will clearly identify this is a series connection. Okay, but I am identify it different way. Up to some item, the color is not changing. After that item, the color will be changed. After this item, the color will be changed. Okay, you can see in this resistor system, the colors of both end of the resistors are different. That means, is it a series connection or parallel connection according to our observations?
Series connection.
Yes, it is series connection. Now I am going to applying R equivalent is equal to R1
plus R2.
plus R2 is 4 plus 8. It is equal to 12 ohm. Is it clear?
Yeah.
Okay. Now I'm going to give you another example. It is 8 ohm, 5 ohm and 2 ohm. Yes, it's 15 ohms. Okay. I'm color it in blue color. Then after the item, its color is changed. After another item, its color will be changed. After that item, its color will be changed. So each resistor have different colors in their ends. So because of that, it is series connection. So I will take it as R1 plus R2 plus R3. That means 5 plus 8 plus 2, it's 15. Is it clear or not? ඒක clear ද හැමෝටම නැද්ද?
Yes, sir.
Okay. Now I'm going to another question which has 20 ohm resistor and 20 ohm resistor. Now, first I'm going to color it. Up to some item, the color is not changing. Up to some item, the color will be not changing. Up to some item, yes, I know. Is it, you can see in this resistor systems, that two colors are same for the each resistor. Is it parallel connection or series connection? According to my color observations. Is it
Series.
parallel? It is parallel connection. It is parallel connection. You can see red and blue, red and blue. It happens only parallel connections. Red and blue, red and blue. Okay. So that this one is parallel connection. So I am applying 1 over Re is equal 1 over 20 plus 1 over 20. That means 1 over Re is equal 2 over 20. So Re is equal 20 over 2. It is equal to 10 ohms. Okay. In this observation, you can see if you have same resistor in number of same resistors, n number of same resistors are connected in parallelly, its equivalent resistance can be write it in this way. There is n number of resistors which have same resistor value R, R, R. Its equivalent resistance can be written in this way, R divided by N. You can apply it into this one also, check it, okay? I will apply it this one. 3 ohm, 3 ohm, and 3 ohm. 3 ohm, 3 ohm, and 3 ohm. You can see in this part, red color, red, 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 red. And this part, I will take green color, green, 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 and green, green. Same colors, that means series connection, sorry, parallel connection. So I'm going to applying 1 over Re is equal 1 over 3 plus 1 over 3 plus 1 over 3. You can see it is 3 over 3. That means Re is equal 1 ohms. You can see if I'm taking one resistor value and divided it into number of resistors, it is also get same results. So this relationship is proved. Okay, is it clear or not? ඒක clear ද හැමෝටම නැද්ද?
There.
Okay. Now I'm moving to another question. What happens if you are connected different type of resistors? This one is R1, this one is R2. Two different resistors in parallel. Same color, same color. This is also get same color. You can see colors of both end get same. So it is parallel connection. So I'm going to applying 1 over R is equal 1 over R1 plus 1 over R2. This is only for the two resistors, okay? We can write 1 over Re is equal R2 plus R1 divided by R1 into R2. So RE can be written as RE is equal R1 R2 divided by R1 plus R2. Is it clear or not?
Okay.
Okay. We can use this relation for these questions also. I'll show you. I'm going to connect two resistors. These are really important concepts. This is 10 ohm. This one is also 10 ohm. And there is another question. This one is remaining 10 ohm and this one is changing into 8. This one is 10 ohm and this one is 8 ohm. This one is 10 ohm and this one is 5 ohms. And this one is 10 ohms. This one is 1 ohm. If I am applying that relation into this one, this relation into this one, we can say RE is equal 10 into 10 divided by 10 plus 10. Then 100 over 20, it is 5 ohm. If I am applying that question in that relation into this one, 8 into 10 divided by 8 plus 10. Okay. That is 18 or 80 over 18. It is 4.44. For this one, do it here. R is equal 5 into 10 divided by 5 plus 10. 50 over 15. It's 3.33. If this one, R is equal 10 into 1 divided by 10 plus 1. It's 10 over 11. It's 0.9. Okay. You can see in this relation, the equivalent resistance is always lesser than the minimum resistance or lowest resistance of the system. Did you see that? Equivalent resistance is always lesser than smaller resistance, smallest resistance in that series, in the parallel connection. Okay. You can see the smallest value is 5, but the equivalent is lesser than 5. Smallest value is 1 and equivalent is lesser than 1. Did you notice that one? Is it clear? Is it clear or not? මං කියපු එක clear ද නැද්ද?
Clear.
Okay. Now I'm going to moving a little bit higher question. Okay. In equivalent resistance, it is not the problem which equation we are applying to the solve this question. The real problem of the equivalent resistance is it parallel connection or series connection? Actually, that's the real problem in the equivalent resistance. Because if we don't understand it is parallel or series, we cannot apply each of these, any of these law. Okay. Any of these law. Okay. So I have already discussed how do we find out is it parallel or series. If it is parallel, there are different values. If it is series, sorry, if it is a series, there is different colors. If it is parallel, they have same color. Am I correct? Is it clear or not? So if I'm discuss another question like this, 2 ohm, 2 ohm, 4 ohm, 4 ohm, 4 ohm, 4 ohm. You have to calculate equivalent resistance in between A and B. So first, what I have do is what I have to do. First, I'm going to color it. Starting from A up to this point, it's red color. Up to this point, it's red color. Okay. Now I'm going to color it in this way. It is green color. And now I am going to color it in this one. It is yellow color. Okay. Now I will color it in blue color. First you have to color it. Now you have to decide which resistors are going to be replaced. Now, first, I'm going to ask you a question. Can I, you can see in this part, can I join these together and calculate the equivalent? Why is that? Why we cannot connect each of them? Because it has different colors now, so we can calculate it as a series connection now. Why we cannot do that? Sorry? Yes, actually there is another resistance. But did you notice in this case, if I am going to connect these 4 ohm and 8 ohm, I have got 12 ohm resistors which has blue color in this way and red color in this way. Am I correct? It's a 12 ohm resistor which has blue color in left hand side and red color in right hand side. Am I correct or not? Is it clear or not?
Yes, sir.
Okay. Then what happened to the green color? It is vanished. Did you see that? That means if you are seriously connected the two resistors, the middle color can be vanished. In this case, if your middle color is the red one, okay. If this red color one is vanished, that means main terminal is going to be vanished. Is it clear? If I am connecting these two, the middle color is red one. You know, when we are connecting series, when we are calculating the equivalent resistance of the series connection, you can see the middle color is always vanished. In this case, middle color is red, and if we are connected these two resistors, the red color will be vanished. If the red color is vanished, that means main terminal is vanished. Is it clear or not? එක clear ද හැමෝටම නැද්ද?
Clear, sir.
Clear. So now, can anyone tell me why I cannot join these two? Why I cannot join that two? These two. Why is that? කාට හරි කියන්න පුළුවන්ද ඇයි මට මේ දෙන්නව කම්බයින් කරලා ගහන්න බැරි කියලා?
Same thing B cannot be
Sorry, it's not clear. Your answer is not clear.
like the same thing
Yes.
terminal B cannot be
Yeah.
vanished.
When we are connecting 2 ohm and 4 ohm, you can see this is also series connection. If we are connecting in this way, this is also series connection. If it is a series connection, the middle common color is vanished. If the middle common color is vanished, that means yellow color is vanished. Then what happened to the 4 ohm? The 4 ohm lose one end of its terminal. One end of it of connection to that circuit. Okay. Then now the 4 ohm is a separate value and this part is separate. Now circuit is separated. So it cannot be connected. Same reason we cannot connect these two together. Is it clear or not?
Sir, can you explain it again, please?
මොන part එකද explain කරන්න ඕන ඔයාලට? නිපුණ මොන part එකද ඔයාලට explain කරන්න ඕන කියන්නේ?
Replace කරන්න.
දැන් ඔයා බලාගෙනද හිටියේ මේක බලන් හිටියද ඔයා?
ඔව් ඔව්.
දැන් මේකේදී ඔයා දැක්කද මේ දෙන්නව join කරාම මැද තිබිච්ච පාට නැති වෙලා ගියා?
ඔව් ඔව්.
දැන් මම ඔය වැඩේම මෙතන කරොත් මේ දෙන්නව combine කරොත් කවුද මේ දෙන්න දැන් මේ දෙන්න ඔයා දන්නවනේ පාට දෙක දෙපැත්තේ අසමානයිනේ. රතුයි කොළයි රතුයි කහයි. ඒ කියන්නේ පාට දෙක අසමාන දෙන්නෙක්. ක්ලියර්ද කියප එක නැද්ද?
ඔව්.
එහෙම පාට දෙක අසමාන
ඔව්,
නම්
ඔව්.
මේ දෙන්න සීරීස්ද පැරලල්ද? සීරීස්ද පැරලල්ද? ආන්සර් කරන්න. මයික් එක අන්මියුට් කරලා ආන්සර් කරන්න. මේ දෙන්න
සමාන්තරගත.
ඔව් සමාන්තරගත ශ්‍රේණිගතද කියලා යහන්න. මේ දෙන්න සමාන්තරගත ශ්‍රේණිගතද නිපුන්?
ඔය දෙක සමාන්තරගතයිනේ සර්.
සමාන්තරගතයි කියලා කියන්නේ කොහොමද? දැන් මෙච්චරලා මේක කිව්වා නේද මම දෙපැත්තේ පාට සමාන නම් විතරයි සමාන්තරගත දෙපැත්තේ පාට වෙනස් නම් ශ්‍රේණිගතයි කියලා කිව්වා ඇහුණාද? නිපුන් ඇහුණාද නැද්ද? කො ආන්සර් කරන්න. ඇහුණාද නැද්ද ඒක මේ ඔයාට ඒක තේරුණාද නැද්ද?
ඔව් ඒ ටික ඇහුණා මට. ඔව්
ඔව්
තේරුණා.
එතකොට දැන් එතකොට මේක තේරෙනවද කියන්නකෝ මේක දෙපැත්තේ පාටවල් සමාන නැහැ අසමානයි කියලා. මේකේ තියෙන රතුයි කොළයි මේකේ තියෙන රතුයි කහයි කියලා තේරුණාද කියන්නකෝ.
ඔව් ඔව් ඒක තේරුණා.
එතකොට මේක ශ්‍රේණිගතද සමාන්තරගතද? මේක ශ්‍රේණිගතද සමාන්තරගතද? කො ආන්සර් කරන්නේ නැහැ.
ඕක ශ්‍රේණිගත වෙන්නේ නැහැ කොහොමද? අර
මේක ශ්‍රේණිගතයි. එහෙම ගත්තොත් ශ්‍රේණිගතයි. ඒ කියන්නේ ඔයාලට මම කියන දේ තේරෙනවද කියන්නකෝ. මේක ශ්‍රේණිගත සමාන්තරගතද කියන්න මට නිපුන්. Yes, it's series.
ශ්‍රේණිගතයි.
ශ්‍රේණිගතයි. ශ්‍රේණිගත නම් දෙපැත්තේ පාටවල් සමානද අසමානද?
අසමානයි.
අසමානයි. දැන් මෙතනට එන්න. දැන් මෙතන මං අරන් තියෙන්නේ 2 and 4 නේ.
ඔව්.
දැන් එයාගේ 2 ගේ දෙපැත්තේ පාටවල් මොනවද තියෙන්නේ?
අසමානයි.
දැන් 2 ගේ දෙපැත්තේ පාටවල් අසමානයි කියලා නෙමෙයි මම කියන්නේ. 2 ගේ දෙපැත්තේ පාටවල් මොනවද තියෙන්නේ?
red and green,
red and green. 4 ගේ දෙපැත්තේ පාටවල් මොනවද තියෙන්නේ?
red and yellow.
එතකොට 4 ගේ දෙපැත්තේ ඉන්න පාටයි 2 ගේ දෙපැත්තේ ඉන්න පාටයි දෙන්නම සමාන values දෙකක් දින්නේ. නැත්නම් සමාන මේ පාටවල් දෙකක් දින්නේ.
නැහැ.
නැත්තම් ශ්‍රේණිගත සමාන්තරගතද? ඒකට උත්තරේ දෙන්නේ. නැත්තම් ශ්‍රේණිගත
Series
සමාන්තරගතද?
connection.
sorry
Series connection.
series connection. ඒ කියන්නේ ශ්‍රේණිගතයි කියලා කියන්නේ. නිපුන්ට ඒක තේරුණාද නැද්ද?
So I will check it. Okay, let's continue.
නෑ ආයි කියන්නකෝ මට තේරුණ නැත්තම්. ඔයා එක මයික් එක මියුට් අන්මියුට් කරන්නකෝ. නැත්තම් මට කතා කරන්න වෙන්නේ නෑ. ඔයා සැරින් සැරේට මයික් එක අන්මියුට් කරනවානේ. අන්මියුට් කරලා පළවෙනිට මේ ප්‍රශ්නේ විසඳගන්න. හරි.
හරි.
දැන් පළවෙනියට මට කියන්න මේක තේරෙනවද කියලා? මෙතන කතාව. මම අහන්නේ equations ටික නෙමෙයි. මේ අහන්න physics subject එකේ equation පස්සේ දුවන්න එපා. concept එක මොකක්ද කියන එක බලන්න. හරිද? මෙතන ඔයාලගේ මේ question ඒ කියන්නේ මේ වගේ මේ විදිහේ question එකක ඔයාලට මේ 1 over re මේ කියන්නේ සමාන්තරගතයි කියලා දැනගත්තොත් නැත්නම් parallel කියලා දැනගත්තොත් ඔයාලට මේක easy මේ දාගන්න පුළුවන් 1 over re කියන කෙනා equal 1 over r1 plus 1 over r2 කියලා. ඒක ඉතින් මහ ලොකු දෙයක් නෙමෙයි. ඒක සමාන්තරගතයි කියලා දන්නවනම් මං හරිද නිපුන්? ඒක සමාන්තරගතයි කියලා දන්නවනම් 1 over r1 1 over r2 කියලා දාගන්න එක මහ ලොකු දෙයක් නෙමෙයි. ඒ වගේම ශ්‍රේණිගතයි කියලා දන්නවනම් r1 r2 r3 දාගන්න එක මහ ලොකු දෙයක්ුත් නෙමෙයි. මං හරිද? හැබැයි ඉතින් ප්‍රශ්නේ තියෙන්නේ ඔයාලා ශ්‍රේණිගතද සමාන්තරගතද කියලා හොයාගන්න එකනේ ගැටලුව තියෙන්නේ. ක්ලියර්ද කියන එක? ඒක ශ්‍රේණිගතද සමාන්තරගතද කියලා ඔයාලා කොහොමද හොයන්නේ? ඔයාලා කොහොමද කියන්නේ? අන්න ඒකට විසඳුමක් තමයි මේ දෙන්න යන්නේ. ක්ලියර්ද කියන එක?
ඔව් සර්. හරි.
එතකොට දැන් මෙතනදී ඔයාට පේනවා ඇති මං කිව්වා item එකක් R1 වගේ item එකක් හම්බ නොවන තාක්කල් හරිද? නැත්නම් item එකක් කියන්නේ resistor එකක් වෙන්න පුළුවන්, cell එකක් වෙන්න පුළුවන්, capacitor එකක් වෙන්න පුළුවන්. එහෙම හම්බ නොවන තාක්කල් එකම පාටකින් පාට කරන්න පුළුවන් කිව්වා ඇහුණා.
ඔව් ඔව් ඔව්.
ඕකේ. එහෙනම් මට මේක red color එකෙන් මෙතනට නිකන් පාට කරන්න පුළුවන්.
ඔව් ඒක හරි
එතනින්
clear.
එහා මට මේක පාට කරන්න බෑනේ මේ පාටින්.
බෑ.
ඒක green color. ওই විදියට ඔයාට ඒක දිගටම ගියා කියන එක පේරුණාද?
ඔව්.
හරි. එතකොට series connection එක ඔයා දැක්කද? R1 ගේ දෙපැත්තේ ඉන්නේ රතුයි කොළයි. මං හරිද?
හරි.
R2 ගේ දෙපැත්තේ ඉන්නේ කොළයි කහයි.
හරි.
R3 ගේ දෙපැත්තේ ඉන්නේ කහයි නිලුයි.
හරි.
තුන් දෙනාගේ දෙපැත්තේ ඉන්න පාටවල් ගත්තාම color combinations තුනක්. රතුයි කොළයි color combination එක තියෙන්නේ. R2 ට තියෙන්නේ කොළයි කහයි color combination එක. R3 ට තියෙන්නේ කහයි නිලුයි combination එක. clearද කීප එක නැත්ද?
හරි clear.
හැබැයි ඔයා දැක්කද parallel connection එකක එහෙම නැහැ. R1 ගේ ඉන්නේ රතුයි නිලුයි combination එක. R2 ගේ ඉන්නේ රතුයි නිලුයි combination එක. R3 ගේ ඉන්නේ රතුයි නිලුයි combination එක. දැක්කද ඔයා?
ඔව්.
එතකොට resistor system එකක් seriously නම් මේ parallel මේ කියන්නේ parallel නම් connect කරලා තියෙන. කියන්නේ සමාන්තරගතව නම් connect කරලා තියෙන. ඔයාලට බලා ගන්න පුළුවන් දෙපැත්තේ color combination එක සමානයි. මං හරිද?
හරි. හරි සර්.
හැබැයි seriously connect කරලා තිබුණොත් ඔයාට කියන්න පුළුවන් දෙපැත්තේ color combination එක අසමානයි කියලා. පැහැදිලිද කියන එක?
හරි. හරි.
දැන් මෙතනට මේක ඔයා series parallelද කියලා කියන්නේ කොහොමද? ඔව් ඉතින් මේක දැක්කාම හැඩයට series parallelද කියලා කියන එක නෙමෙයි. ක්ලියර්ද කියන එක? හැඩයට series parallel කියලාත් කියන්න පුළුවන් අවස්ථා තියෙනවා. කියන්නේ මේකේ shape එකේ හැඩයට මේක නිකන් series වගේනේ. කියන්නේ ශ්‍රේණිගතයිනේ ඔය විදිහේ shape එක ගත්තාම. එහෙම කියන්නත් පුළුවන්. නමුත් මම මේ කියන්නේ ඕනම එකක් විසඳන්න පුළුවන් concept එකක්. පළවෙනිට මම color කරගෙන යනවා අපවසරයක් මුල ඉඳලා. ක්ලියර්ද කියන එක? මේක blue color. හරිද? resistor එකක් තිබුණාන් පස්සේ ඒකේ color එක blue වලින්ම පාට කරන්න පුළුවන්ද මට ඊට පස්සේ?
බෑ.
බෑ. එහෙනම් මම වෙන color එකකට මාරු වෙනවා. ඒක green color කරා. පැහැදිලිද කියන්නේ? ආපෞසරයා resistor එක connect කරාන් පස්සේ මට green color වලින්ම පාට කරන්න පුළුවන්.
බෑ.
බෑ. එහෙනම් මම ඒක red color වලට මාරු කරා. මං හරිද? දැන් දෙපැත්තේ color combinations ගත්තාම දෙන්නගේ සමානද අසමානද? දෙන්නගේ සමානද අසමානද? color combination එක ගත්තාම
අසමානයි.
අසමානයි. එහෙනම් series එක parallelද? sorry මේ සමාන්තරගත ශ්‍රේණිගතද?
ශ්‍රේණිගතයි.
ශ්‍රේණිගතයි. ඒ කියන්නේ ඔයාලට පේනවා දෙපැත්තේ පාට අසමාන නම් අපිට ශ්‍රේණිගතයි කියලා කියන්න පුළුවන්. දැන් ඔයා මේකේ හැඩය ගැන හිතන්න එපා ඈ. හරිද? හැඩය ගැන හිතන්න නැතුව මම මේ දෙන්නව කන්ටැක්ට් කරනවා. හරිද? මේ දෙන්නව මම ජොයින් කරන්න ගියොත්. මෙයාගේ මේ 2 ohm ගේ තියෙන දෙපැත්තේ පාටවල් මොනවද?
red and green.
4 ohm ගේ තියෙන්නේ.
red and yellow.
එතකොට color combination
Color
සමානද
combination
අසමානද?
අසමානයි.
එහෙනම් සමාන්තරගත ශ්‍රේණිගතද?
ශ්‍රේණිගත.
ශ්‍රේණිගතයි. ක්ලියර්ද කියන එක. හැබැයි ඔයා දන්නවා
ඔව්.
ශ්‍රේණිගත සම්බන්ධතාවයකදී ඔයාට පේන්න ඇති මේ මැද ඉන්න කෙනා හැමතිස්සෙම හැල්ලා ගියා. කියන්නේ දෙන්නටම පොදු වෙච්ච කලර් එක හැල්ලා ගියා. දැක්කත් දන්නවා. නිලුයි කොළයි තිබුණාම කොළ හැලුණා. මං හරිද? කොළයි රතුයි තිබුණාම කොළ
ඔව්.
හැලුනේ. ක්ලියර්ද කියන එක. කොළ පාට
ඔව්
හැලුණා.
ඔව්.
එතකොට මෙතන හැටියට දෙන්නටම පොදු කලර් එක මොකද්ද?
red නේ.
රෙඩ් එක හැලුනොත් මේන් ටර්මිනල් එකට මොකද වෙන්නේ?
එතන loop එකේ ගැටලුවක්
ඩිස්කනෙක්ට්
එනවා.
වෙලා යනවා. ක්ලියර්ද කියන එක. දැන් මං ඊළඟට ඔයාගෙන් අහන ප්‍රශ්නේ මේ දෙන්න ගත්තොත් සීරියස්ද පැරලල් ඒ කියන්නේ සමාන්තරගත ශ්‍රේණිගතද?
ඒකත් අර විදිහම සමාන ශ්‍රේණිගත.
ශ්‍රේණිගතයි. ශ්‍රේණිගත නම් දෙන්නගේ කවුද කොමන් කලර් එක වෙන්නේ?
yellow.
yellow. එතකොට yellow හැලුනට අවුලක් නැද්ද අපිට? yellow ඩිස්කනෙක්ට් ලා ගියට අවුලක් නැද්ද? yellow කලර් එක දැන් අපි මේ දෙනවා ජෝඩු කරොත් yellow කලර් එක හැලනවනේ. මං හරිද මේ කවුද නිපුන්? මං හරිද කීප එක නැද්ද?
ඔව් ඔව්.
yellow
ඔව්.
කලර් එක හැලුනට අවුලක් නැද්ද අපිට? ප්‍රශ්නයක් නැද්ද කියලා අහන්න.
ප්‍රශ්නයක් නෑ.
ප්‍රශ්නයක් තියෙනවා. මොකද දන්නවද? yellow කලර් එක ඔයාගේ අතින් ඩිස්කනෙක්ට් වුණොත් එහෙම වැරදිලාවත්. ඒ කියන්නේ ඔයාගේ yellow කලර් එක නැති වෙලා ගියොත් එහෙම ෆෝම්ට මොකද වෙන්නේ? ෆෝම් එක නිකම්ම ඩිස්කනෙක්ට් වෙනවා ඒ සර්කිට් එකෙන්. ක්ලියර්ද කීප එක නැද්ද?
හරි සර්. ඔව් ඔව්.
ඒක පරිස්සමින් කරන්න
දැන්
ඕන දෙයක්. ඊළඟට මං අහන්නේ මේක. ෆෝම් එකයි ෆෝම් එකයි ෆෝම් එක කනෙක්ට් කරන්න පුළුවන්ද? ෆෝම් විතරයි. ඒ කියන්නේ මේකයි මේකයි කනෙක්ට් කරාට අවුලක් නැද්ද? Is it okay if I am connecting form and form? It is also in series. Is it okay or not? ඒක ඕකේද නැද්ද? කවුරුහරි ආන්සර් කරන්නද? නිපුන්?
Not sir.
එතකොටත් සර් yellow එක common හින්දා ඒක dismiss වෙනව නේද?
ඩිස්මිස් වුණොත් මොකද වෙන්නේ? 2 ohm එකට කනෙක්ෂන් එක නැතු වෙනවා.
ඔව්නේ.
ඔව්. එහෙනම් මම අහන්නේ 4 ohm උයි 2 ohm උයි ගත්තට කමක් නැද්ද?
එතකොට සර් ඒත් yellow එක dismiss වුණාම අර
යට
යට
form
තියෙන
එක හැල්ලෙනවා.
form එකට
අන්න හරි.
connection එක dismiss
ක්ලියර්ද
වෙනවනේ.
කියන එක?
ඔව්.
දැන් එහෙනම් ඊළඟට මම අහන්නේ 2 ohm උයි 2 ohm උයි ඕකේද?
It's okay sir.
It's okay. green color එක loss වුණාට අපිට කිසිම issue එකක් නැහැ. Because green color is not connected to anyone. So I am going to combine this one. In this case, you can see the colors are different. Color combination is different. Red and green and yellow. So if I'm connecting this one, we can get 4 ohm resistor from here. And this one is also 4 ohm. This is form, and this is also form, and this one is also form. Clear? This is A, this one is B. And this one is red color one. Okay, this is red color one. And this is yellow color one. Am I correct? This one is yellow color. Green color is vanished. Green color is vanished. This one is blue color. Now, can I combine these two? මට මේ දෙනව combine කරන්න පුළුවන්ද? දැන් කවුරු හරි? Can I combine these two?
No.
No. Why is that?
If we connect that one, the yellow color
Yellow
will
color
be
is lost. Then yellow color, if the yellow color is lost, this form resistor is also disconnected. So we have to connect these two. When we are connecting these two, you can see the colors are same. Color combination is same. Red, yellow, red, yellow. So color combination is same. We can see it is parallel connection. If it is parallel connection, and also the same resistor in both resistors are same, we can use 4 divided by 2. It is 2 ohm.
2.
Yes, it is 2 ohm. It is 2 ohm, and this one is also 4 ohm. Now the color combinations are, this one is red, this one is yellow, this one is green. Sorry, this one is blue. This is A, B. Okay. You can see if you are connecting 2 or more resistors in parallel way, any colors are not vanished. Any of these colors are not vanished. ඒ colors කිසිම එකක් vanish වෙලා යන්නේ නැහැ. ඒ colors දෙකම තියෙනවා. පැහැදිලිද නිපුන් මේ කතාව කියන්නේ ඔයාලට?
ඔව් සර්.
ක්ලියර්ද මේක මේ ගත්ත විදිය අපි?
ඔව්.
ඕකේ. මොකද parallel the series කියලා හොයාගත්තොත් apply කරන එක මහ ලොකු දෙයක් නෙමෙයි. ක්ලියර්ද කියන්නේ? හැබැයි parallel the series කියලා හොයාගන්න එක තමයි ලොකුම දේ. ක්ලියර්ද කියප එක? parallel the series කියලා හොයාගන්න එක තමයි ලොකුම දේ. Now I'm going to combine these two. It is in series, so equivalent resistance is 6. It is 6 ohm. Now, from that knowledge, there are a lot of things. I will take another example. This is the last question, what I'm doing in today. Okay. Now, this one is 6 ohm, and this one is also 6 ohm. This one is 4 ohm, and this one is also 4 ohm. Okay. Now, do it and send me the answer. Do it and send me the answer. Do it and send me the answer. මේ question එක මම මේ questions ටික මම කොහොමද සර්ට යවන්නේ? ඔයගොල්ලෝ මේ සේරම ටික කරන්න. හරිද? අර අන්තිම question එක නම් පොඩ්ඩක් නැහැ මේ. මගේ අතින් මං හිතන්නේ ඒක මේ record වෙලා නැහැ. මේ part එක. මේ question එක record වෙලා නැහැ මං හිතන්නේ. Okay. කමක් නැහැ. හරිද? questions ටික මේ ටික කරපු අය දන්නවනේ කරන්නේ කොහොමද කියලා. ඕකේ කලර්ස් ටිකත් එක්ක මේ question එක මිසින් කරපු විදිහ මම පස්සේ ඉල්ලුවොත් එහෙම මම කරලා දාන්නම් වෙනම question එක. ඕකේ. මේ තියෙනවා drive link එක මෙන්න මේක තමයි. මං හිතන්නේ ඒක වෙන්නේ. ඔව්. ඒක තමයි. ඒකේ අර white board දෙකක් තියෙන්නේ. ඒ white board දෙකේ තමයි ඔය කියන ටික තියෙන්නේ. ඒ ඕපන් වෙනව නේද? ඔව් ඕපන් වෙනවා. ඔව්. එතන සේරම මේ white board එකේ කරපු ටික තියෙනවා. ඒ ගිහිල්ලා බලන්න voltage calculations ටික ඒ ටික සේරම තියෙනවා. අද මම කතා කරේ equivalent resistance and Kirchhoff laws. ඒ ටික through යන්න. එතකොට එක්සෑම් එකෙන් පස්සේ මම පුළුවන් වුණොත් අපෝසරයක් මේ ඔයගලන්ට ඉන්ඩක්ෂන් කරා කියලා කිව්වා. මම ඒ වුණාට ඉන්ඩක්ෂන් පාර්ට් එක ඔයාලට ඕන නම් අපෝසරයක් කරන්න මම කරන්නම්. අයිඩියා එකක් ඕන නම් තව මේ ඊට වැඩිය පොඩ්ඩක් කියන්නේ තේරුම් ගන්න හරි අයිඩියා එකක් ගන්න හරි ඕන නම් මම ඒක කරලා
Sir,
දාන්නම්.
tell in English.
Okay. If you
The induction pathway is
so I have done in previous weekend this week I have done up to Kirchhoff's laws. If you need to do another day school another pass session for induction part also, I will conduct it or after the 11th of February, because up to 11th we have also CAT. So do you need pass session for the inductions?
Okay.
Yes, sir.
Okay, I think we have already done one pass session for the induction. For my techniques, actually what I am going to do in induction session is I am going to introduce my concept into that induction part. Same theories in some short
Because
methods.
we can't sub attendance that one, so okay.
So are you doing pass session? No, I'm not doing pass session for any other subjects. I'm only senior mentor for the physics. I'm conducting these days. I'm conducting only pass session for basic electromagnetism. We are not doing pass session for other subjects. We have done one pass session in general thermal physics. I think I don't know how many pass sessions I did for that one. PHU 3202, no, because they didn't say us to do the pass session for PHU 3202, the wave session. It is easy, no? That one is easy. If you thoroughly go through the book, you can get good grade. Okay. Any other questions? Actually, I'm extremely sorry. I forgot to record this question. If student will, there are a lot of students, no? If student asking this question, I will do it again and upload it. Okay. Okay. Thank you, sir. Okay. You're welcome.
සර් අර
Thank
මේ
you,
මේ
sir.
කලර්ස් මේ ඔය ඩයග්‍රෑම් කලර්ස් කරපු ස්ලයිඩ්ස් දෙක තුනට පොඩ්ඩක් මූව් කරන්න පුළුවන්ද?
මේක මේ ටික නෑ මෙතන.
මුලින්ම තියරි එකට ගත්ත එක ගණන් හදපු එක නෙමෙයි. තියරිස් වලදී පෙන්නපු ටික
මේක.
ස්ක්‍රීන්ෂොට් එකක් ගන්න.
මේක මම මේ ස්ලයිඩ්ස් එක එවන්න.
ස්ලයිඩ්ස් ටිකක්
මේ
තියෙනවා.
ස්ලයිඩ්ස් එකත් මට දාන්න පුළුවන්. මේකත් මම දැන් සේව් කරගෙන ඉන්නේ මෙතන. මේ ටික සේරම දැන් මම රෑ අප්ලෝඩ් කරනවා.
ඕක ෆස්ට් ස්ලයිඩ් එක ඕකද? කලර්
මේ
ඕකයි
කලර්
ඊළඟට
කරපු එකේ
ආ නෑ
මෙතන
ඕක
තමයි
නෙමෙයි. ඔතන ඉඳන්නේ.
මෙතන ඉඳලා දිගටම තියෙන්නේ. ඇත්තටම මම මේ ක්ලාස් එකේ කරේ චුට්ටයි. හරිද? මේක ඒ කියන්නේ හුඟක් දිග ලෙසන් එකක්. කියන්නේ මේක
සර් අර දෙවෙනි ස්ලයිඩ් එකට දාන්නකෝ. පළවෙනි එක නෙමෙයි දෙවෙනියට මූව් කරපු
මේක
කලින් එක.
මේකටද මේකටද
ඕක නෙවෙයි ඊළඟ එක.
මේක
ඔව්.
ඇතර මෙතන තියෙන්නේ පොඩ්ඩයි සෑහෙන්න ගණන් ගොඩක් තියෙනවා ඒ ගණන් ටික through යන්න ඒ ගණන් වල සමහරක් ඒවා මම simultaneous equation අතින් සුළු කරලා ඇති ඒවත් බලන්න ඔයාලට අතින් සුළු කරගන්න ඕන නම් simultaneous equation මොකද සමහරක් ගණන් තියෙනවා simultaneous equation අතින් සුළු කරන ඒවා ලේසි වෙන ගණන් සමහරක් ඒවා ඒ වගේම වින්ස්ටන් බ්‍රිජ් එක through යන්න මං හිතන්නේ දැන් ඔයාලට අපිට ඉතුරු වෙලා තියෙන්නේ capacitors ටික කරන්න විතරයි ඉන්ඩක්ෂන් සෙෂන් එක ඔප්ෂනල් සෙෂන් එකක් විදිහට යන්න ඕනේ මොකද ඉන්ඩක්ෂන් පාර්ට් එක කරලා තියෙන නිසා Coulomb's law වලට අදාළ වෙන I have already uploaded the previous year past sessions for the Coulomb's law and other potential calculations. Please go through that. I don't remember if there is recording for the capacitors too. I will check it. And actually we don't have those links. I saw those links are shared in your general and thermal physics group. Okay. Please check it and okay. From here, I will wind up the session. And if you have any question, please ask me now. Otherwise, I will